This is SW321, SW421, Software Project Management at Fairfield University, and I'm going to talk through the slides from Wysocki, 8th edition, Chapter 7, How to Plan a TPM Project. I've forgotten the number in the 6th and the 7th editions, but they're basically the same slides as for this particular chapter. Okay, so as usual, we start off with there's tools, templates, and processes that we need to apply to plan a project. We've got to be cognizant that planning is important, right? You've got if you don't plan, you're going to fall into a hole. Planning means you're thinking ahead, you're thinking about what you've got to do. And get it right. And to do that, you use information about stuff you've done before. So sometimes you might want to use software packages to plan projects, sometimes not. We'll talk a bit about that. You really should have a joint project planning session, a JPPS. This involves all of the stakeholders, potentially with a facilitator from outside the stakeholders, to figure out what the project's about. You need to put together from the requirements breakdown structure, a work breakdown structure which goes into more detail about, instead of what you're going to build, which is what the requirements tell you, the work breakdown structure is more about how you're going to do it, who's going to do it, when it's going to be done eventually. In all of that, you need to do a lot of estimation. How long is everything going to take? How many people do you need? What's it going to cost? You can then figure out how to start from where you are with potentially nothing to where you need to be, and you can put together a project network diagram that links all the tasks from beginning to end. Because sometimes you can do stuff in parallel, right? You don't have to do things one after the other necessarily if you've got multiple people working on the project. And then the aim of this phase is to get approval to actually launch the project. And that approval is based around the project proposal. The project proposal takes the project overview statement, that one-page document, and fleshes it out into a more fully featured document with much more detail about how the project is going to complete what it's doing and what the benefits of the project are to the organisation. And then at the end of that, hopefully you get approval and you can then go launch the project, which is the next phase. So here's a simple diagram to show what a good planning session will give you versus a poor planning session. And it's in relation to the amount of pain you're going to go through, right? A good planning session will try and break the back of all the big problems in the project early on. That means early on in the project should have the highest pain level, the highest amount of effort that you've got to put in, whether that's intellectual, potentially financial. It's perhaps the most painful, but sometimes the most rewarding part of the project is breaking the back of all those hard details. And the trouble is, poor planning is just going to push all that stuff off, or not even recognize what the problems are, and then they blow up right at the end of the project, which stops you finishing. So here's the three things that planning helps with. It reduces uncertainty. A project, when you first start it off, when it first pops out of the CEO's head or whoever idea generator's head, is a lot of uncertainty. It might have a clear goal, but there's no necessarily details about how to get there. So planning is to flesh out that nebulous idea. The other thing that happens is when you do planning is you talk to other people about it. And when you talk to other people about it, they may have a different viewpoint about particular aspects, and that may enhance your understanding of the project and theirs. So it's a useful activity just from an understanding or a communication viewpoint. And then the other thing it does is it improves efficiency. It means everybody should know what they need to do, when they need to do it, well in advance. So it's a good thing to do. Should you use software packages? We've got Microsoft Project on all the machines in our lab. We can do that. It's useful for large projects, for distributed teams, and if we use lots of vendors or contractors or outsource a lot. If it's a small project, if the project duration is in small increments, if using a software package adds too much non-value adding work, or if we've got a lot of volatility in what we're trying to do, a software package may not be the best thing to use. So what should you use instead of a software package if you're in the no category there? Well, sticky notes. They're quite useful for doing things. Index cards is something that people used before sticky notes became popular. Marker pens, right? And a big whiteboard to put them on and to move them around and make them visible to everybody. So they're the things you can put on sticky notes: the task ID, the unique task name, the duration, who's going to do it, or rather the labor that's associated with it, who's going to do it, who's the manager, the earliest start date, the earliest finish date, the latest start date, the latest finish date, and then whether it's on the critical path. So what the marker pens let you do is they let you define dependencies between the tasks that you've got to do. And it lets you identify the critical path. So the critical path is the basically the path that limits how quickly you're going to get the project done. If anything on the critical path slips in its schedule, then the whole project slips its schedule. Sometimes if things slip a lot on the critical path, then the critical path moves, and things that were not on the critical path previously become on the critical path. So here's something you can use a whiteboard, or a lot of things you can use a whiteboard for: the project overview statement, the work breakdown structure, if it's a smallish one, the dependency diagram, some project schedules, resource schedules, an issues log, right? All those things. Sometimes you may need a few whiteboards for some of these things. So there's always an issue with planning, taking the time to plan, and that is it takes time away from development. And here's some rules of thumb about how long planning should take. And if it's a large project, maybe it takes 3 to 4 days. If it's a very small project, maybe it only takes an hour to do the plan. But you should still think about the plan. So when you're putting together the joint project planning session, you need to pull together a few things. You need to pull together the people, the attendees. You need to pull together the facilities you're going to use, the place you're going to have it, any equipment you're going to use, audio-visual equipment perhaps, or something else. You need to put together an agenda. As I think I've said, never go to a meeting that doesn't have an agenda. If the meeting doesn't have an agenda, you're just going to waste time. So have an agenda. You need to sort out what your deliverables are outside of the joint planning, project planning session, and the main outcome of it should be a project proposal. The people who go to the joint project planning session are the facilitator, the project manager, maybe another project manager to help out and give a different perspective, maybe a consultant on planning, on project planning, technographer. The core team of the project should be there. The customer or client representative should be there. The people who manage the core team should be there, and other parts of the team that you may want to pull in later once you start launching. You need the project champion, or what I would call the product owner, the person who is really invested in seeing the project to fruition. You may need functional managers from HR and legal and finance and sales and marketing. And you want a process owner. You want somebody who's invested in making sure that the process of the project is followed. So facilities, you want something comfortable, away from interruptions, potentially breakout rooms if there's breakout sessions needed. You need tables, chairs, flip charts, projection equipment, whiteboards, similar sort of stuff that I talked about earlier. So there may be 3 sessions. Negotiate the conditions of satisfaction, build the requirements breakdown structure, write the we should already have a project overview statement, and then have the kickoff, and then potentially a working session about the plan. So session 1 involves the project manager and the client. Session 2 adds the team, the people you know already. Maybe you don't know everybody yet, but you know. And then session 3 is about the project manager and the entire team. So here's what you do with the planning kickoff. You introduce the sponsor. The sponsor can give an overview of the project. You need to introduce the client co-project manager, the person from the customer side who's invested in getting the thing done. If you've got an IT co-project manager, then you need to have them involved. The core project team should be the main technical leads or QA leads are there. And then if you have a facilitator, then you may want to introduce them. You want to go through and validate all the requirements, prioritize them. You want to get an overview of the approach you're going to take. You need to generate and validate the work breakdown structure. You need to do estimates of all the duration, labor, and resource requirements. You need to create a dependency diagram. You need to discuss the critical path and when you're going to finish. You need to figure out whether you can compress the schedule and analyze that. What are the risks? What are your mitigation plans? And agree on what you've produced as the project plan, and then have an adjournment. So somebody's already written the project overview statement. So you've got to review that for clarity. You've got to create the work breakdown structure, which should be based on the requirements breakdown structure. You estimate task duration and the resource needs. You construct the network diagram. You figure out what the critical path through that diagram is. You revise and approve the schedule. You figure out who's going to do everything, the resources, and you gain consensus. Make sure people agree with the project plan. So there's some things that the client must do. They have to be involved. If the client is not invested, all bets are off. Right, a work breakdown structure is a hierarchical description of the work you're going to do. You start with the requirements breakdown structure, and then the work breakdown structure is a superset of that, so it adds more detail under the activities. Right, so here's a diving down into the more detail, and then you can group activities together, or the tasks associated with each activity, into a work package that somebody can pick up and execute. So why do you put together a work breakdown structure? It's a thought process tool. It's an architectural design tool. It's a planning tool. It's a project status reporting tool, right? You can use it for all those things. So there's various ways to convert from a requirements breakdown structure to a work breakdown structure. And which is best depends on the project, it depends on the team. So you may take a top-down approach and just start with the RBS and drill down, or you may start with what the team understands about the RBS and get them to put together a series of tasks that they think need to happen, and then try and match that up into the things in the work breakdown structure. So when is it complete? Well, we've got we're able to measure the status of things and the completion of things. We've got every activity is bounded and has a deliverable. We can easily estimate the time and cost. The duration will finish the work within a good time frame, and we don't have too many people overloaded, or we don't have anybody overloaded, so the work assignments are independent. So there's lots of things you need to think about. If the client didn't participate, or if you have some sort of a discomfort with it, or you're likely to have a big scope change, then choose a life cycle that accommodates frequent change. Sometimes you've got to have exceptions. You've got to stop before completion criteria are met. And you may need to decompose the completion criteria into more details. If you're getting any of these things, you've got a really short duration project, you may want to micromanage it. If you have high risk activities, you want to decompose them to isolate the riskier parts. Or if the things are looking, if the duration has a large variance, you may want to figure out why that variance is there. So here's what I was saying about the work breakdown structure being a superset of the requirements breakdown structure. There's the RBS in the yellow, and the WBS is the enclosing cyan color there. So how do you build a work breakdown structure? There's these ways of doing things, and I'm going to look for a in an in-class activity to try and show you how to do some of these. We've got to do the requirements breakdown structure first, then we'll do the work breakdown structure afterwards. So here's an example of a graphical work breakdown structure for building a house. It's got relatively high level stuff, but it's got all the components of the house and identifying what we need to do to finish the house. Here's another way of showing the same sort of thing, an indented version rather than a graphical version. And here's a work breakdown structure for a waterfall SDM. Right. So it's often good to find or create a work breakdown structure template. It saves you time. It helps you build on prior experience. It standardizes it, so when you look at it, you're looking at the differences from normal rather than everything being different. It gives you a structure and a checklist for making sure you complete everything, and it helps you focus on the quality improvement efforts. So here's some typical recurring projects: update a new application, install the network field office, develop new training materials. I talked about this last week, so that I'm not going to go into too much more detail, but the key here is that you cannot say that an 8-hour day is going to produce 8 hours of usable work. In this particular instance, where people work at a 75% efficiency rate and have a 33% of interruptions in their day, then you move from having 10 hours of labour to taking 20 hours of work. Right? So it may not necessarily always be like that, but it's certainly not 10 hours of labour for 10 hours of duration. So estimate duration to build the schedule. Estimate labour when you have to contain expenses, right? So if you're time bound, you need to do the duration piece. If you're cost bound, you need to do the labour piece. And sometimes you need to chop and change between the two, depending on what situation you find yourself in. Right, so sometimes, and as I think we will see in the Brooks book, throwing more people at the problem is not going to help you. Here, going from one person to two people for the indicated task gives us a pretty big bang for buck. But then going from 2 people to 3 people means we take more time. And going from 3 people to 4 people means we take even more time. So think about the right staffing level or the right resourcing level. There's lots of things that cause variation in durations, varying skill levels, just efficiency of work time, unexpected events, mistakes, misunderstandings, in my opinion, are one of the biggest problems here. There's variations in within the capability of the system and common cause variation. So here's 6 methods, and I'll try and put together in our in class time some activities based around these. Having data from previous activities is gold. So keep that previous activity. Ask an expert. Ask the team and apply the Delphi technique. Get estimates from however, get a worst case, best case and average and use the 3-point technique, or use wideband Delphi, which is a modification of the Delphi system. Right, here's the Delphi system, or the Delphi technique. You ask the team, and the first time you ask them, you get a wide variation. And then you ask people to explain how they got their estimates, and you have another pass, and people go together again, and we get a slightly less variation in the estimates. And then we explain again why we chose that, and then maybe we do a third pass and we get even less variation, and we choose the middle value or the median value for that. The 3-point method is this one here. So the estimate we're going to use is the optimistic estimate, the pessimistic estimate, the most likely estimate, and sum those to 4 times the most likely estimate, and then divide those by 6, and that gives us our 3-point method estimate. Estimates have a life cycle, right? The more you do the work on this particular project, the more you understand what you have to do to get things done. And then not only do you need to estimate for people, but you need to estimate for office space or equipment or money or materials. So there's lots of things. So you need to align activities and staff with the skills that are required, the skills that they have. And that's what this is, that's all this is saying. You need to have an organizational structure, right? Who's going to be doing what, and who's going to be designing, who's going to be programming, who's going to be testing. And you need to have that reasonably organized up front so that people don't keep treading on each other's toes. The tester doesn't start doing design work when when 2 people are doing the design work. Okay, so estimating the cost. You're never going to get this exactly right, but you need to do the top level numbers. You need to estimate not only salaries but equipment, capital expenses, maintenance expenses, and you need to figure out how you're going to do cost control. I talked a little bit about Gantt charts in the first lecture. So here's a simple Gantt chart. You've got the design task, the build task, the test task, and the install task. If you have a series of tasks that feed into each other, then this is what you may end up with in your network diagram, right? The task information is on the arrows, and the nodes are, if you like, milestones or checkpoints. Right, so this one's task on the arrow, this one's task on the node. Slightly different representations. And oftentimes you'll see in this all of this information. right? The earliest start time, earliest finish time, latest start time, latest finish time, an ID for the task, how much slack there is, and an estimate for the task. Right, there's some different diagramming conventions about how you indicate in A that A needs to feed into C, in B that E and F both have to feed into G before G can start, and C that both E and F need to can only start once D is done. And there's different dependency relationships. This is a finish to start relationship. A finishes and B starts. Finish to finish means that both finish, or when A finishes, then B may finish. Start to start, when A starts, B may start. And start to finish is when A starts, B may finish. Depends on what relationship between the different tasks are. And there's lots of dependency, right? Technical, management, inter-project, dates, lags. So we'll talk about those in our planning session. And there's a couple of ways that we need to go through the network, right? The forward pass gives us the earliest schedule. We start from left to right, from start to finish, and it estimates the early start and early finish numbers. The backward pass is the late schedule. We go from right to left, from finish to start, and it determines the late start and late finish numbers for the whole project. Right, here's the forward schedule for this network, and we can see that we're going to maybe take 12 units to get it done. Each of the numbers inside the green boxes is the duration of each of the tasks. So for example, D has a duration of 5 and E has a duration of 2. And so we can maybe get done in 10, or maybe get done, or rather it's going to start at 10, it's going to finish at 12. And then going backwards, we try and do the same thing, and we can figure out what the latest schedule is. And you can see for the top path there's no changes in the numbers, but there are changes for the bottom path. That means that the top path is the critical path. There's no slack in what's happening. That's why it ends up being red in the next slide. Right, and that's the early start, late finish. The early start plus duration minus the late finish, or late finish minus duration minus early start gives you the slack. The total slack is the time that the project can be delayed without impacting the early schedule. Free slack is the time that can be delayed without impacting the early schedule of its successor tasks. Whatever you do, don't plan to use slack to bail out the project. It never works. So this is another thing we should do in the planning session. So we'll talk about that, and we'll work through this dependency diagram. And this is just about how do you pull back information, right? You try and want to compress the schedule as much as you can. So instead of putting finish to start dependencies in, you put start to start dependencies. You maybe replace a team member with a more skilled team member. Maybe you add resources, right? Where you add them is the key, though. You add them to the critical path tasks, to high risk tasks, or with tasks that you expect to have large duration variances. Right, so here's some examples. Original critical path with the diamonds on it, and changing from finish to start to finish, we get a slightly different critical path with the triangles on them, and then changing CD from finish to start, we get the circles, or well, I'm not quite sure. No, they're squares. They're squares. So schedule compression doesn't come for free. You might like to think about what those changes mean on the diagrams we have there. And always have at the end of the project a separate task called variously the management reserve, the pad, the buffer, right? Do not pad individual activity durations. That's bound to cause failure. You do need to pad, but you pad the whole project right at the end of the project. A single task right at the end of the project. And then you manage that pad. It gives you a single place to look for how much slack you've got, how much leeway you've got, and it gives you visibility into what you're doing. So once you've done all that, you've got all the planning together, you've got the project proposal. Well, you need to put together the project proposal. You need to take the project overview statement and flesh it out. And here's the sections of the project proposal, and then you need to get approval for it, right? You may get disapproved for cost benefit. Maybe the fear of failure is too high. Maybe we don't have enough money to fund it right now. Maybe there are other projects that are more of interest to the C-suite. Okay, that is chapter 7.